And starting with page 1 of your note packet for exam 2, we're going to start with the properties of exponents. And at this point, you should have received some videos already about these properties that you'll want to review first. But we'll go through a brief summary of these. The first one that we're going to look at is the product rule that says if you multiply like bases, you add the exponents together. And an example of this is x to the 5th times x to the 3. We multiply like bases by adding those exponents together to get x to the 8th. For the quotient rule, it's a similar idea. When you divide like bases, you subtract the exponents, and there's the example of that. Power rule has really two parts. One is just raising a term to a power, and in this case a to the m raised to the n power. To get rid of those parentheses, we multiply the two powers together, and for this we have x to the 3rd raised to the 4th power, which is x to the 12th. Power rule part 2 says if we have more than one variable, or it doesn't even have to be a variable, a number and a variable, inside parentheses, what you're going to do is raise each of those to the outside power. And an example of that would be, for example, 4x cubed squared. Everything inside is going to be raised to the 2 power. This is really 4 to the 1 raised to the 2 power. So 1 times 2 is 2, and x to the 3 raised to the 2 power, or x to the 3 times 2. And then going ahead and simplifying. After that, we have negative exponents that we can talk about. With negative exponents, really what that's saying is you're going to flip the base and change the sign of the exponent to positive. So if it's a to the negative m, we flip the a to 1 over a, and then raise it to the positive m power. Another way of thinking about this, again mentioned in previous videos, is you can think about a line being drawn in here, and when you cross the line with the variable and the power, it's going to change the sign of the power. So x to the negative 3 is up in the numerator right now, and when I drop it down below the line to the denominator, it becomes 1 over x to the 3rd power. Same is true if the negative exponent is down in the denominator. When I cross the line going up, it acts like a toggle switch, and it's going to change it to a positive exponent up in the numerator. So 1 over x to the negative 5 becomes a positive x to the 5th. And again, the sign that changes is the 1 up in the exponent. Nothing in front of the term changes. It's just the exponential sign that changes. The last one is the 0 exponent rule, and that says if you take any base and raise it to the 0 power, with the exception of 0, the answer is going to be 1. So it doesn't matter what's inside here. When you raise it to the 0 power, the result is going to be the number 1. There's a few common errors that you'll want to read through down here with the exponents. And again, some of these were addressed in previous videos that you'll want to take a look back through. What we're going to look at now are a few examples, and this should be on your page 2 of your notes so that you can follow along. We're going to be using some of these properties mentioned on page 1. The first one is when I multiply like bases, I add the exponents. So to simplify this, you multiply the numbers like you normally would. 4 times 5 is 20. And then m to the 2 times m to the 1, all total you end up with 3 m's, or m to the 3rd power, n to the 3 times n to the 4, and again you have 3 n's and then you have 4 more n's. When multiplied together, that gives you 7 total. And that's as far as you can go with that problem. These aren't the same base, so I can't do anything with the exponents. For B, similar idea, using the quotient rule. I'm taking 6 to the 15th divided by 6 to the 9. The bases are the same, so the property states that I subtract the powers. So 15 minus 9 gives me 6 to the 6th power. And that's something that you can simplify using your calculator. 46,656. For letter C, this is using one of our power rules that says everything inside is going to be raised to this outside power here. Now, be careful with the negative in the 3. The negative is also being raised to the power, so I keep it as -3 in parentheses, raised to the 4th power, x to the 4 raised to the 4th, multiply them together, and then y to the 2 raised to the 4th. Once again, multiplying those powers together. So from here, -3 to the 4th power would be taking the number -3 times itself 4 times. So -3 times -3, and then -3 times -3 again. So all total, that'll get you a positive 81, x to the 16, y to the 8th. When you use your calculator, if you're going to use your calculator on this, make sure you put the -3 in parentheses and raise it to the 4th power. Otherwise, you will come up with a sign error. For D, this one looks a little intimidating, but I see that it's raised to the 0 power. And using that property on page 1, anything to the 0 power is automatically the number 1. I don't have to do anything inside here to simplify. When I raise it to the 0 power, it makes it a 1. For letter E, this one has a lot going on. We have what appears to be two terms being multiplied together and also being raised to powers. So we're going to take care of the powers first and then do the multiplication. So I'm going to raise everything to the -3 power first. So that's 2 to the -3, C to the -3, and D to the -3. Then I'm going to raise everything inside to this parenthesis to the 2 power. So that's going to be times 4 squared. And then I have C to the 6 and D to the 2. I can do a couple of different things here. I can go ahead and get rid of the negative exponents. That would be these 3. These 3 have positive exponents, so they're going to stay on top. So 4 squared, I'm just going to simplify that to 16. C to the 6, D to the 2. Because these have negative exponents, they're going to drop down below my line here. So it's going to be 2 to the -3 on top becomes 2 to the +3 below the line. C to the -3 on top in the numerator becomes C to the 3 in the denominator, and D to the -3 in the numerator becomes D to the +3 in the denominator. Simplifying even further, because I have C's both in top and bottom and also D's, let's take a look at 2 to the 3rd, 2 times 2 times 2. I have C to the 6 over C to the 3, D to the 2 over D to the 3. And I can think about this intuitively as maybe 3 separate problems. 16 divided by 8 is just the number 2. 8 goes into 8 once, into 16 twice. I have 6 C's written across the top, but I have 3 C's written across the bottom. So if I cancel a C for a C, I end up with 3 of those C's on top. I have D to the 2 on top, which means I have 2 D's written across the top. I have 3 of them written across the bottom. So if I cancel a D for a D, I'm left with 1 left over on the bottom. It's not necessary that you put d to the 1. You can leave it as just d.